Okay, adding and subtracting fractions are almost exactly the same process. So I'm just going to show a couple of examples of adding fractions, and then I'll show you at the end how subtracting would work. It's almost exactly the same, except one little difference at the end. Okay, and there's two cases to consider. The first is, what if the denominators are alike? So here they're both sevenths. Okay, the denominator is the number on the bottom, and it tells you the kind of fraction it is. In other words, 1/7 is think of a pie, and 1/7 of a pie is a particular size chunk. So it's a particular fraction we're dealing with. And the question is, how many of them do we have? Well, here we have 2 of them, and here we have 3 of them. So here's the thing that we are going to be adding up a bunch of. So if you have 2 of them plus 3 of them, you're going to have 5 of them. So you're going to have 5/7. And that's it. So that the denominators are alike, in other words, they're the same kind of fraction, the numbers on top just tell how many of those fraction pieces we have. So here's 2/7 plus 3/7 is 5/7. And that's it. Let's look at the second case. So the second case is, what if the denominators are not alike? And then the problem is, we got to make them alike. If I can do something to these fractions to make the denominators alike without really changing the problem, then we can follow the same rule as we already saw, and that'll do it. Okay. Now the key to getting the denominators alike, first of all, is to factor these denominators. So notice that 12 can break down into things that multiply together to give you 12. So for instance, 3 times 4. Okay, except 4 will break down to 2 times 2. So 12 overall is 3 times 2 times 2. All right, let's do the same thing for 18. Well, you might think 2 times 9. 9 and 9 is 18. You might have thought 3 times 6. Doesn't really matter. We'll get to the same place in the end. 9 is 3 times 3. And so here we have 2 times 3 times 3. 3 times 3 is 9 times 2 is 18. 3 times 2 is 6 times 2 is 12. We got it. Okay. Now the question is, what do we need in order for these two denominators to actually be the same? For these numbers to be the same, they're going to need the same list of factors. So here I have a 3, I have 2 2's. Here I have a 2 and 2 3's. So let's take this one at a time. Let's look at this list and say, what does this number have, the 18 here? What does this number have that this one lacks? Well, this one has a 2, but that one already has at least one 2. This has 2 3's. This only has one 3. This needs another 3. So put a 3 in the list, and what we do is we put a 3 in the top and bottom. This is sort of the reverse of reducing a fraction. If I multiply top and bottom by the same thing, it's really multiplying it by 3 over 3, which is just 1. That doesn't change anything. It just changes the size of the numbers, but the overall fraction has the same value. Okay, so now we have a list of 3, 3, 2, 2. Turn it around, go the other way. What does this list now have that this one lacks? Well, this has 2 2's, this only has one 2. So we need another 2 here, so I put the 2 there, put the 2 here and here. I have to multiply top and bottom by the same thing. Now, look at these denominators. 3 times 12 is 36. 2 times 18, that's also 36. I made the list of factors the same, and so the resulting numbers are going to be the same. Okay? Okay, so now what are these numerators? 3 times 5 is 15. 7 times 2 is 14. 15 plus 14, well, if it was 15 and 15, it would be 30, so 15 and 14 must be 29. And that's our answer. Okay, 29/36. Okay, now, I told you there was only one slight difference if this were going to be subtraction. So let's say, here, let's undo this last part. Let's say this is a subtraction problem instead of an addition problem. we're going to have the same denominator as before, which is 18 times 2 is 36. But up here I have 15 minus 14. 15 of them minus 14 of them is 1 of them. And now I have 1/36. So if I have an addition, I add the numerators. If it's subtraction, I subtract the numerators. And that's the only difference between adding and subtracting. Getting the denominators to be the same is the same process in both cases. Okay, so if you can do this, if you can factor the denominators, and then we go through that little sequence of steps where we have made the two denominators alike, and so now the problem can be handled just like we did the first one. And that's it.